Hi, my name is Erwin. Welcome to my YouTube channel entitled Rad Horizon, where I aim to chronicle my personal journey into the world of AI web development and design for medicine. As far as disclosures go, if there are ideas which I quote from others, the links will be on my slides as QR codes for your easy reference. So let's get started. So why am I here? I was recently invited to give a short presentation about my personal views on AI and machine learning with respect to Philippine radiology. I've already spoken about my personal journey into AI by building my web app called Radlens. I tackled ethics in AI for medicine and AI in healthcare in other platforms for public speaking engagements. So I've decided to compress and summarize some of those prior presentations and add a few more bits of information with regards to our current situation with COVID-19. So this is my current outline for my presentation. I'll focus on a short recap of my journey and why I started studying AI. Hopefully, I can shed some light on where to start, or for those of you who also want to learn a little more about AI and machine learning. I'll then introduce a few scientific papers which I found particularly interesting with regards to AI and COVID-19. I'll then end with my final message. I've mentioned this already in some of my prior presentations. It's always my main objective, and I cannot say it often enough. So if you forget everything, forget my story, my slides, my entire presentation, except for one thing, just one thing, I hope it's this. AI model performance is not clinical outcome. I picked up this idea as I was learning more and more about AI, so the idea is not exclusive to my presentation. Later on, I'll be sharing an exceptional article discussing this written by an amazing radiologist, Dr. Luke Ogdenreiner. So let's begin with part one, my personal journey into AI, machine learning, web development, and design. I'll start with my current story and what I learned so far. So let's start with the trigger. Why did I start learning more and more about AI? So this is Geoffrey Everest Hinton. I could say a lot about him, but nothing sums it up more than what others call him, the godfather of deep learning or AI. So he's definitely not a nobody. He was awarded the Turing Award along with two others, and he also made the statement, "We should stop training radiologists now." Oh, by the way, that's a QR code on the left. You can take a snapshot of the slide. The code will take you directly to the YouTube video. He said a couple of other things, but I prefer not to play those since I don't want to instigate a flame war. That's not the point of this presentation. So instead, I did some research and came up with these. So let's start with why AI will not replace radiologists. This is an article by Dr. Hugh Harvey, written in 2018. It's an amazing 9-minute read. The QR code takes you directly to that article. Some of the interesting points in that article were the following. We don't just look at images. There's also the issue of responsibility, human or machine, and then there's productivity and demand. I think the most important point here is responsibility. You don't see a machine signing out a report, or if it did, the question would be, who would be responsible if it made a mistake? If there's no radiologist, will the AI vendor be willing to take up the liability? The data scientist, the computer scientist, the AI engineer. This is another article entitled "A Machine versus Doctor Fixation Masks Important Questions About Artificial Intelligence." The main point for me in this article is, it's 2020 and there are still no reports of radiologists losing their jobs. So what's the problem? Geoffrey was wrong. There's nothing to fear. AI is just a fad. Why waste time on this? What is the lurking danger in the sea of deep learning and AI? So AI is not a sentient creature that's here to kick you out of your workstation or take away your job. But why is there such a push for it? So here is an article discussing robots and management. My interpretation of the article, as applied to radiology, would be this. On one hand, it's really expensive to train and pay for a radiologist. A radiologist goes through what? 9 years of med school? 4 to 6 more years of subspecialty training, maybe even more. On the other hand, it's currently expensive to train AI as well today. But think about when a good working AI model is finally achieved. It could be easy to replicate and deploy, as easy as copy and paste. AI may not always be better, but when mass produced, it can be cheaper. So what was I to do? This was my problem. I had no formal computer science background. I had very minimal biostatistics in pre-med, but I had a lot of questions. So this was basically my solution. I did a search online for courses. I read the documentation. I studied the web, a few languages like HTML, CSS, JavaScript, PHP, studied some Python, and then finally I picked a machine learning library. So after all the online searching, this is pretty much where I started with AI, Google's machine learning crash course. I had to learn Python, but I don't think you need to write the Python code to understand the basic concepts of machine learning, like stochastic gradient descent. Google develops a machine learning library called TensorFlow, and that is what I use. So what did I build? So what is RadLens? It's a personal project. It's an ongoing project. It's not FDA approved as a medical device. And no, I am not selling a product for launch. What I do have is an idea. The idea that if I built this, you can too. I'm not saying you can build your own AI radiology startup from scratch. You need an entire team of professionals for that, including computer scientists, data scientists, and doctors. But rather, what I hope is that you can build to better understand how AI might better serve its purpose in your own field of practice. So here's the demo. You click on the camera button at the lower right. The app starts scanning with your phone's camera. You focus on a forearm fracture. It will try to guess that fracture, and then it asks you. So in this case, it asks you if that is a Montague fracture. Now, if you tap or click on the word Montague fracture, it acts as a hyperlink. That takes you to a Google image search showing you more pictures of a Montague fracture, so you can check for yourself if the AI is right or wrong. Simple enough for a hobby project. So what could I do with this personal hobby project? So this web app became my entry to a DevPost hackathon. It was also mentioned on the TensorFlow Dev Summit in 2020. I won't go into the details, but there are QR codes on the slide for your reference. And here are QR codes to the actual web apps if you want to learn more about how they work or how I built them. I won't go into the details anymore because I think what's more valuable now is, what have I learned? So if there's one slide that matters the most here, I think it would be this. It comes from the article, Medical AI Safety, Doing It Wrong, by Dr. Luke Odenreimer. He's a radiologist. So here he focuses on actual world implementation, not just model performance, and states that model performance, if we were doing drug development, is similar to the stage of simulation studies or animal models. So my interpretation of the article is, if someone came up to you and said their brand new shiny drug has 90% effectivity on animals, would you immediately give that drug to your patients? So what exactly is performance testing versus clinical testing? So with performance testing, it's usually laboratory testing where you control all the factors, save for the actual AI model. You have various metrics involved. For clinical testing, it's in the context of real healthcare, where you don't control all the variables, and you actually focus on real clinical outcomes. So here we have an article entitled Failing Loudly. an empirical study of methods for detecting dataset shift. The key statement in the abstract for me is that machine learning systems tend to fail silently. So, what does this mean? You can read the article for a more concrete explanation, but I'll try to explain with my own analogy, not from the article, as I understand it as a radiologist in the context of our local Philippine practice. So, this is not from the article. This is just my own analogy or interpretation of population or concept drift in respect to Philippine radiology. So let's start with a simple thought experiment. In fact, this is more of an oversimplification, but please bear with me, just so I can point out the concept. Let's say you start with 90% TB distribution in a population, let's say a town, a clinic, or a hospital. If the AI model diagnoses positive for PTB all the time, so it never says negative, that's 90% accuracy. We treat the tuberculosis down to 10% distribution. The AI model is unchanged and still diagnoses PTB as positive all the time. The accuracy now has been reduced to 10%. This is a theoretical example of an AI model obviously failing loudly, given the changes in the distribution of disease or population shift. This theoretical example, however, never happens in real life because no one ever sells an AI system that can only diagnose PTB as positive. That's ridiculous, and that is obvious. But what happens when it's not so obvious? So let's consider another example. 90% TB distribution in a population. So that's 90 people with TB in 100 patients initially. The AI model now can actually diagnose either positive or negative for pulmonary tuberculosis. We treat TB down to just 60% distribution. The AI model is unchanged. How does this affect the AI model? Will the AI model start overdiagnosing PTB, or will it start underdiagnosing PTB? How do we measure the effects of that population shift to the accuracy of the AI model? The answer is not so obvious anymore. What is the threshold for the shift in disease distribution before we decide, hey, maybe we should retrain the AI, or maybe even test the AI? Because maybe it's not performing optimally anymore. We don't have to be data scientists or computer scientists, and as doctors, radiologists, we should have some idea to know when the AI system or model we're using is failing. It's like radiographic positioning and radiation physics. I am not a rad tech, nor am I a radiation physicist, but I do know when an image is no longer diagnostic. I know when an ALV lacks angulation. I know when beam hardening artifacts cause streaks on a CT scan. I know when metal affects the signal of an MRI, so I know when that machine fails and needs fixing or recalibration. But how do I know when an AI system or machine learning model fails, especially when it fails silently? It's hard to determine when AI models fail because AI models are hard to explain, which brings me to another concept I'd like to discuss: the AI ML model as a black box. Machine learning models are literally called black boxes. Why? Because you don't really know what's going on inside. We know there's math inside, but a machine will usually not explain itself to you. In terms of radiology, I think the closest analogy would be this. When I was training as a resident and my amazing mentors would grill me to the bone regarding an image, it would always go like this. Is there a lesion? Meron o wala? If there is, then where is the lesion? And finally, why is that the lesion? Explain that lesion. What is wrong there? What is happening there? What is the pathophysiology? Why are you pointing to that? As a human trainee, you have to answer because you are not a black box. On the other hand, AI won't explain itself outright. Sure, AI might put a box around the lesion or segment out the lesion, but it still won't tell you why it did that outright. This area of AI is currently heavily under research. Lots of new metrics are appearing for this, including chat values. However, the machine still doesn't explain itself the way a human does. Machines don't initially explain why it thinks in a certain way. We know, however, that there's a whole lot of math involved. As radiologists, when we talk to clinicians, we don't dump a whole lot of math on them. We explain as a human would. So I'd like to touch on the following lightly. This is basically statistics, but I just wanted to specify that the word accuracy is thrown around a lot when it comes to AI, especially when it comes to the AI outperforms doctor hype train. The accuracy I was discussing earlier refers to the accuracy on the left, or basically how many did the machine get right out of all its guesses. It is rarely used now because of the problem I explained earlier. I just used it to make the effects of population or concept drift more obvious. The more popular metric used now for machine learning models, however, is AUC, or area under the curve. They are not the same. AUC is currently more popular, but it is not always better. It is also not the only other metric for model performance out there. There are a lot. The point I just want to make here is that we need to be careful how the word accuracy is used. But in the end, accuracy is still a measure of model performance, so that's okay. But what we're really interested in is not just model performance, but clinical outcome. So this ends the first part of my presentation. Now for a quick review. So we discussed time and how population shift or drift or covariate shift can affect the performance of the model. We also tackled the interpretability of the AI ML model, which is usually considered now as a black box. We also touched upon metrics, some of the metrics used, such as accuracy and AUC, or area under the curve. These points will be nice to consider when tackling the AI studies for COVID-19 later on. Last December 2019, I was lucky enough to be allowed to attend a lecture from Professor Andrew Ng, who's a big name in AI. It was made possible by AI Pilipinas and Deep Learning AI. It was an amazing lecture and tackled a lot of concepts for AI ethics in general. AI ethics for radiology and medicine is beyond the scope of this current presentation, but you can check out the video if you're interested. Now for part 2, AI and COVID-19. So for my second objective, I'll be trying to apply what I've learned when reading AI studies for radiology. So here are a few recent studies which I found particularly interesting regarding AI and COVID-19. So this is a nice study entitled Artificial Intelligence Distinguishes COVID-19 from Community-Acquired Pneumonia on Chest CT. Now for some key points. It's a retrospective study. It's a multi-center study. It uses CulpNet neural architecture. And over 4,356 chest CT exams were taken from over 3,322 patients. Now for the key results. One of the nice things to note here is that it uses more than just accuracy and uses one of the metrics I introduced earlier, namely the AUROC, or simply AUC, area under the curve. But even more important is the last key result, where it states that there is still an overlap in the chest CT findings of all viral pneumonias, and that a multidisciplinary approach is encouraged. So even with really good AUC values, the overlap of chest CT imaging findings remains. That, at least, is my take-home point of this recent study. Here is an editorial reflecting on the previous study, So it's not a new study, but rather it notes a few key points about the study I explained earlier. First, it talks about ResNet 50 as being the backbone of the neural network and that future initiatives can use other state-of-the-art or newer architectures. Second, it was asking for more information regarding the results of the UNet architecture used for lung segmentation. And third, it was basically asking for more details regarding the full source code. So the editorial was not trying to put down the previous study in any way. It was just pointing out a few key points of interest. So my take-home point from this is that after reading any study about AI medicine, it's always best to wait a while and see if there are new articles that might seek to review these studies. It's always best to see AI studies as a spectrum of various research articles instead of reading each one in isolation. Now, this one study is really interesting. Unlike the prior one, which was a retrospective study, this one has a prospective component. It has data from 3,777 patients. It produced both a diagnostic model and a prognostic model. The prognostic model used both radiologic CT parameters and clinical data. It used a lot of metrics, not just accuracy and AUC, but also used Dice coefficient, pixel accuracy, sensitivity, and specificity. AI model performance was also evaluated from data in China and Ecuador. There were also comparisons between the AI model versus junior and senior level consultants, as well as juniors using AI. So there's a lot to talk about in this study, but for radiologists, I think what might interest us the most would be the comparison between AI and RADs. The study claims that the AI model performance was overall superior to junior radiologists and comparable to mid-senior radiologists. So that was one of the more comprehensive studies out there. I ended up asking a few more experts in AI and medicine that I met along the way about it, and I just thought I'd share some of my own conclusions and opinions. First, let's review. I personally try to avoid reading AI research studies in isolation, so this last study was relatively new. I'm still waiting if there are new articles or studies that will review or shed more light on its methodology. For my part, I was looking at the prospective component, and the prospective part extended from early February to the end of March. So that's basically only 1 to 2 months. But then again, there really isn't much prospective data to begin with since COVID-19 is really new. But let's give credit where it's due. It's a really extensive study. But is a good study all we really need? A good study is always a great starting point for a firm foundation in the application of AI in radiology. But for it to properly work, we also have to ask how the promising results of a study can be properly integrated into our own specific radiology workflow. How will it match our specific needs and requirements, which may drastically be different per institution? Things like internet speed or data connection or upload time or computer processing power can all affect the successful integration of a promising AI model. So these things we must consider, not just the study on paper. Now, specifically for the Philippines, this is my particular question. How will an AI model trained elsewhere fare with an image of pulmonary tuberculosis with superimposed or intercurrent bibasal pneumonia? I've read that internationally, COVID-19 is not generally associated with mediastinal lymphadenopathy or cavitation or pleural effusion, and that the findings are usually bibasal, peripheral, ground glass. Now, what if we have a known case of pulmonary tuberculosis with bilateral upper lobe infiltrates and they suddenly exhibit bibasal opacities? PTB is often referred to as a great mimic, and I just wonder how it will affect the performance of an AI solution, particularly in our country. So for my final message, I remember when I was a med student, and eventually when I was a resident, Dr. Romano would always end with this in his lectures: Kaizen, the need to continuously improve. AI is not an enemy, or an adversary, or even the end, but just another opportunity for us to continuously improve. So, with that in mind, I'd like to end with this word: Ikigai, a reason to live. Sometimes I wonder if I should be angry with all the experts out there claiming that AI outperforms Dr. Radiologist. I guess I'm a little angry, but mostly I feel challenged because being angry changes nothing. In a way, maybe some of what has been said is true. Maybe we should stop training radiologists. We should stop training radiologists in a vacuum where AI is not part of our expertise. Instead, we should train and prepare our juniors and ourselves for the AI ML world that is to come. I don't think that data scientists, computer scientists, or AI engineers are the enemy. These are people, and we all just want to build a better future. But the technology does offer a challenge. So when it comes to the challenge of AI outperforms radiologists, let's not answer with anger. Let's not answer by turning a blind eye or pretending that AI does not exist. Instead, let's wear that armor. Let's pick up that hammer, and let's prove to the world that radiologists can still do this all day, and that we are still worthy. Because in the end, AI, machine learning, technology, these are all just tools at your disposal. In the final analysis, you are the ad hoc razor. You are the rad edge.